Hello, my darlings. This set of notes is looking at parallel and perpendicular lines along with solving simultaneous equations. So kind of mixing some topics together here. So things you need to remember for this are parallel lines, remember, have the same slope, the exact same slope. Perpendicular lines have opposite reciprocal slopes. So that one's a little trickier because it's the positive 1/2, negative 2, or negative 5/4 and positive 4/5. So the signs have to be opposites and the numbers have to be reciprocals of each other. All right, so here it says to graph both lines. So we are finding the equation of the line parallel to the given line through the given point, and then we're finding a solution. So first thing we want to do is graph this given line. So this has a slope of 3 and a y-intercept of 5. So I put my y-intercept of 5 and then up 3 to the right one or down 3 to the left one, and that gives me that green line right there. So now I want a line parallel to that line but going through the point -2, -3. So I graphed my point, and then I used the same slope, up 3 to the right one, up 3 to the right one, and that gives me this blue line. And the equation, if you recall, point-slope form is what I'm looking for here. So point-slope form, remember, is y minus y1 equals m times x minus x1. So I'm going to use this point, and my slope is 3. So y minus -3 becomes y plus 3 equals the slope, which is 3, and then x minus -2 becomes x plus 2. These lines are parallel to each other, so there is no solution. They do not intersect. All right, so this one, a little trickier first because this is in standard form. But I can graph easily from standard form. If I plug in 0 for y, this term disappears. So if 2x equals 12, then x equals 6 is my x-intercept. And then if I plug in 0 for x, this term disappears. So if 4y equals 12, then y equals 3, and that's my y-intercept, and I can just draw a line through those 2 points. Okay. But I need to know the slope of this line, so I can either take this and basically solve for y, so subtract 2x and then divide by 4 to find out that my slope is -1/2. Or you could just use rise over run, where if I go down 1, 2, 3 to the right 6, I also get a slope of -1/2. So now I'm going to graph the parallel line. So I graph this point, 6, -4, and then I used my slope of -1/2. So I went up 1 to the left 2, up 1 to the left 2, and that draws that blue line. So the equation of that blue line in point-slope form, well, again, I'm going to use this point, and my slope is -1/2. So y minus -4 equals -1/2 times x minus 6. And again, these lines are parallel, which means there is no solution. All right, so example 2, we're going to do the same thing but with perpendicular lines. So first thing I did, again, is I draw this line, which is the same one up here. So it had my y-intercept at 5, slope of 3. So that's that green line. Perpendicular lines have opposite reciprocal slopes, though. So if this is a slope of 3, the perpendicular slope is a -1/3. So I graph the point 2, 1, and then I go up 1 to the left 3, up 1 to the left 3, and I can draw my line. So the equation for that blue line is going to use this point and my slope of -1/3. So y minus 1 equals -1/3 times x minus 2. And I look right here and see where they intersect, and my solution is the point -1, 2. All right, so again, graph the green line. Well, that's that line right there that we already graphed up here in the first example. And this line, if we recall, had a slope of negative 1/2. So our perpendicular slope is going to be a positive 2. So using this point, I graphed the point 3, 4. My slope is 2, so up 2 to the right 1, up 2 to the right 1. Draw the line. The equation for that blue line, I'm going to use my point and my slope. Y minus 4 equals 2 times x minus 3. So again, that's y minus y1 equals m times x minus x1. Little reminder, it's been a while. That was first semester integrated 1. And then we look and see, where did the 2 points cross? Well, they crossed right there at the point 2, 2. So that's our solution. Okay, so that finishes up parallel and perpendicular lines mixed with simultaneous equations.